We're going to be looking at question 1, and this is one variable calculus 15 points, and in this video we're only going to be solving the first question, which is A. And the question says that verify if the following series converge, that is the sum from k equals to 1 to infinity of k squared minus 1 over 4 raised to the power k. So in this case our series is given in terms of k, so our definition of this series needs to be in terms of k. So what do I mean by that? The first thing we need to do is to define our function, right? To define our function here, we're going to call our function ak, and this function is the sum from k equals to 1 to infinity of k squared minus 1 divided by 4 raised to the power k. Now notice that I've named it ak, and the reason for this is because our series of course is in terms of k, and if our series was something like x squared minus 1 divided by 4 raised to the power x, then our definition will be ax. So this is just a variable, and you can really name it with anything you want. It can even be f of k, b of k, and whatsoever. Right? So in this case we're going to go with ak, and the question says verify if the following series converge. Now a new term comes in, converge, right? You now ask yourself, what does it mean for a series to converge? So this is where the conditions for convergence comes in. Now when a series is convergent, there are certain conditions it needs to obey. So meaning that if the limit, right, as k tends to infinity of the absolute value of ak plus 1 divided by ak, if this limit is less than 1, then we can safely conclude that it converges. Now if the limit as k tends to infinity of the absolute value of ak plus 1 divided by ak is greater than 1, then it diverges. And finally, if the limit as k tends to infinity of the absolute value of ak plus 1 divided by ak is equals to 1, it's unconclusive. So what this means is you cannot tell if it's a convergent or a divergent series. Then you need to either use different methods to verify the convergence or divergence. So you have to have this in mind. Just keep this somewhere in your mind. So after knowing that, okay, these are the different conditions for convergence and divergence, the first thing you need to do is to come up with all the terms, right? To come up with all the terms. And in this case we have ak plus 1, and we know our ak plus 1. So in this case our ak plus 1 simply means anywhere we see k, we replace it with k plus 1 in our series ak. So meaning that our ak plus 1 will simply be k plus 1 all that squared minus 1 divided by 4 raised to the power k plus 1. So if you want to ease like your workload, what you can do is to further simplify this. So you can further simplify this in order to avoid simplification in the future. So what you only do this once you gain a certain level of experience. And simplifying this simply means expanding this and expanding this as well. But I won't expand now, just to show you at the right time why you need to expand and what will help you to know which function to expand. And of course this is a composite function made up of a quadratic function in the numerator, which is k squared minus 1, and an exponential function 4 raised to the power k. So you need to have that in mind, because at certain levels when you're taking the limits of a function, you need to know which functions are there, because there's usually this function priority, where if you're comparing two functions, oh, I think I'm getting out of the scope. So now the question here, we have to really verify this condition, the first one. So the first condition is a condition of our interest, right? So we're going to look for the limit as k tends to infinity of So I have to put this here, k plus 1 all that squared minus 1 divided by 4 raised to the power k plus 1, and here we're going to have our ak is k squared minus 1 divided by 4 raised to the power k. So this is actually the limit we're looking for, the absolute value of this limit. This is what we want to verify. Now, for the sake of not repeating myself, I won't be writing the absolute value signs all the time. So if you're doing this in an exam, know that you have to do it, especially if you're giving points for the different steps you're taking. So in this case, we're going to simplify our result. This simply means the limit as k tends to infinity. You know what? I'll just write them. So this will simply be the absolute value of k plus 1 all that squared minus 1 divided by 4 raised to the power k plus 1 multiplied by 4 raised to the power k divided by k squared minus 1. So I'm sure we all know what I did here. I simply inverted it because it was a division sign. I changed it to multiplication, and I had to change the numerator to be the denominator. This is a rule you need to know. Now, what will guide me here is how can I proceed, right? It's not very easy to see the limit from here, and the only thing that can help you is to further simplify it. And you notice that there is 4 raised to the power k here, and somehow I can derive 4 raised to the power k here, and with that in mind, it's going to guide me to know which function to simplify. In this case, this is what I need to simplify: 4 raised to the power k plus 1, and there's no way in which you can simplify this in order for it to cancel out, right? So this is how you know which function to simplify, right? So in this case, we know from indices, right? It's very easy. From indices, we know that multiplying two indices of the same base, we simply add the power. And it is the same thing if we have an index raised to the n plus 1, we can still write this as this. Alright, so with that in mind, we're simply going to write the limit as k tends to infinity of k plus 1 all that squared minus 1 divided by, here we are going to have 4 raised to the power k multiplied by 4, then multiply by 4 raised to the power k divided by k squared minus 1. So we clearly cancel 4 raised to the power k. Once you're able to cancel this, it just makes your work simpler, right? And notice that even if so in any case, right, if you just want to look for the limit, let's say inserting k equals to infinity in your function, which is generally what you need to do when you're looking for the limit, you see that you're going to have 4 raised to the power infinity plus 1, which is infinity, and up in the numerator you also have 4 raised to the power infinity. So infinity divided infinity, you cannot tell what the answer is or what the result is, because these are different infinities. So you cannot simply just cancel infinity with infinity. So you need to simplify it using this step in order to know, right? In order to simplify it and know that once you're inserting your infinity, it's either 1, it's either 0, or it's just infinity in the numerator or in the denominator for you to conclude. But once it's in both the numerator and denominator, it's very confusing. So that's why that's something you can actually consider when simplifying, right? That's just an aside. So in this case, we can continue by looking for, right, let's continue by looking for now the limit as k tends to infinity of our function. Now in this case is 1/4. Now the reason why I factor this is because it's a constant. We're simply left with k plus 1 all that squared minus 1 divided by k squared minus 1, where this absolute value. From here, I can already tell that the limit of this function is 1. And once you have a certain level of experience, you will be able to know this. And in an exam, you don't need to show all the steps. If you're able to know that the limit of this function is 1, you can just go ahead and write the answer and then state your reasoning, right? Now, how did I know that the limit of this function is 1? So generally, when you're looking for the limit of a function, you need to consider the functions involved. If it's a quadratic and a quadratic function, the limit will be 1. and in this case the numerator is a quadratic function, and the degree of the highest power of the degree of this quadratic is k squared, and it's the same thing in the numerator. The highest power of the degree is also k squared. And when you're looking for the limit as a function tends to infinity, what is most important is the function with the highest degree, right? You need to really understand this. So to simplify this, let me further simplify it by expanding our function. So k plus 1 squared is k squared plus 2k minus 1. What I've done is simply expanding this. Actually it's plus 1. I've expanded k plus 1 squared. So minus 1 then divided by k squared minus 1. So this is the same as, well, we know that we are taking limits. I'm just simplifying. So this will be k squared plus 2k divided by k squared minus 1. Now we're going to factor out k squared in the numerator. We'll be left with 1 plus 2k all over k squared divided by k squared. We'll factor out k squared in the denominator. Will be 1 minus 1 all over k squared. We notice that what our k is going to cancel, our k squared is going to cancel, so we'll be left with the limit as k tends to infinity of 1 plus 2 all over k divided by 1 minus 1 on k. Then we need to know that the limit, right? You have to take note of this. We need to know that the limit as k tends to infinity of 1 all over k is usually 0. You have to know this. So in that case, when we insert our k equals to infinity, we're going to have 1 plus 2 raised divided by infinity. So this is 1. It can be 100 or 1000, anything, any number, any constant. It can be c. But we know that a constant divided by infinity is 0. So this is going to give us 0. This is going to give us 0. And we'll be left with 1 divided by 1, which is 1. So meaning that all of these will be 1, and therefore our result will be 1 divided by 4. And this is less than 1. Then we can conclude that then it converges. So that's the solution.